Now we're going to look at an example of hypothesis testing for two population variances. Here we have a county school that has a school bus contract, and we're going to look at the variance of arrival or pickup delivery times as the primary measure of quality for the bus service. So we have two different companies, Millbank and Gulf Park, and we want to see whether the variance of delivery and pickup times for the two companies are the same or not. And we want to use alpha of 0.1 or 10%. And we have sample data, which is right here. It's 26 arrival times for Millbank, 16 arrival times for Gulf Park, gives respectively a sample variance of 48 and 20. And we want to test whether the variances are same or different. So let's set up the two populations, the two population variances. So arrival and pickup delivery time for Millbank, Gulf Park, and the variance of Millbank, variance of Gulf Park Company. And the null and the alternative hypothesis on the alpha value being 10% is given like that. And then we have the sample sizes and the sample variances are given. Okay, like that. Now the test statistic is S sub 1 squared divided by S sub 2 squared. And we want to, when you're using table from the textbook, we need to make sure that this F is greater than 1. In other words, the larger variance should go in the numerator and the smaller one should go in the denominator. But when we're using Excel, it really doesn't matter. Whichever way, all you need to do is to make sure that you set up your F table value and the P value correctly. So here it so happens that the first S sub 1 squared is larger than the S sub 2 squared. So F will be larger than 1. And then the numerator degrees of freedom is the n minus 1 for the numerator sample, and n minus 1 for the denominator sample is the denominator degrees of freedom. Then the F table value, okay, so here is where, depending upon whether the numerator variance is larger or the numerator variance is smaller compared to the denominator, in a two-tailed test you can set up a right-hand side tail or a left-hand side tail. So here, since this is greater than 1, the numerator is larger, our F dot INV should be dot RT. And since this is a two-tailed test, we have to take alpha and divide by 2, and then we provide the 2 degrees of freedoms. Degrees of freedom for the numerator and the degrees of freedom for the denominator. So this will give us the F table value, and if the F statistic is larger than the F table value, which in this case is so then we reject the null hypothesis. Okay. Now we can do the test using p-value. So for p-value, again, you need to make sure that you need to consider whether it is the numerator is larger than the denominator or not. In this case, it is larger. So we use F dot dis dot RT. Okay. And the F statistic value and the 2 degrees of freedoms, this will give us the upper tail area. Okay. Now, if this is a one-tail test, then this will be the p-value. But this is a two-tail test, so we have to multiply by 2 to get the p-value. And the p-value is 8.1%. And with alpha being 10%, since p-value is less than alpha of 10%, then we reject the null hypothesis. And so the conclusion will be, the interpretation will be that we do have sufficient sample evidence to conclude that the variances are not the same. They are different between the two companies. Okay. So the probability that this conclusion is wrong is 8.1%. It's less than 10%.